Hi everybody, welcome to today's webinar where we're going to talk a little bit about Creo NC for beginners. So I'm Pierre Venter, so let's just quickly go around the agenda. So I think you all received this, what we're going to show today and what we're going to do. So I'm just going to do a quick introduction, boundary systems, and then we'll jump into the demonstration. And I'm going to do some milling stuff today. And we'll talk about the turning and some of the other features that's available in Creo as well. After that, we'll do a quick question answer session, and you can use the GoToWebinar tool to send those questions to me, and I'll answer them. If I can't answer them, and I'll get back to you. So just a little bit about myself. So I'm on the technical side at Boundary Systems. I've been using Creo manufacturing for about 8 years now. I'm also responsible for the post-processor development for the Creo product. So just quickly, a few things about Boundary Systems. So you'll see a few logos of the customers we serve. We also, some of the technology we provide, some PTC, solid thinking, iterate, some of those things. I think the important ones here, the product lifecycle management, data management, CAD design and consulting. So those are a few things we help these customers with. Some of the accreditations. So again, the important ones here that I just quickly want to show out is the Winchell Certified Implementer, PTC Preferred Service Provider, and also Certified Training for PTC products. So some of the other products we do, PTC, obviously the main one over there, solid thinking, iterate, and we do ZWCAD as well. Then as we start with the NC stuff, always important as a beginner or as you start using the software is to know what you have and what capabilities you have. So this is just the one slide I quickly want to talk about. And you will see there's about 4 options when you start looking at the manufacturing side of Creo. So we've got the prismatic and multi-surface milling extension. So that's the basic package. So you get two axis feature-based machining, 3-axis milling, and then you can do 5-axis positioning milling as well. So that's where you take a part, you turn it a certain degree, and you apply a 3-axis toolpath to it. Then you turn that part again, and you apply a 3-axis toolpath to it. So nothing simultaneous over there. Then the production machining one, I think that's the more popular option, where you get the same as with the prismatic and multi-surface milling, but you get the turning and the wire EDM with that. So you get 4-axis turning with that and 4-axis wire EDM. So quite a big jump over there and really adding a lot of value if you're doing turning and wire EDM as well. Then we've got the complete machining, where there's just a little bit extra more on the 5-axis stuff and on the multitask machining. So on the 5-axis stuff, that's simultaneous machining. On the turning stuff, you're adding live tooling that you can do, and also the synchronization of multitask machines. Okay. All of these comes with the GPost things where you can generate your post processes. We normally develop that for the customers, and you also get the simulation in all of these packages. Okay. The mold machining is something new available in Creo. We're doing a webinar on that next week, so that's just more some of the latest toolpaths and things that you can use in Creo. I'll go briefly over it when we do the user interface within Creo, but I'm not going to share anything on that today. I want to try to keep it simple today. It is for beginners, so positioning parts and things like that I think is a little bit more important for today's webinar. And then next week we'll go a little bit more into the mold machining and look at the type of toolpaths we can create there. Okay, so I think that's the slides. Oh, there's one more. So if you have any technical questions, you can drop me a mail. I'll get back to you, answer them if I can. If I can't, then I'll get the right person to do that or refer it to PTC. Sales questions, there's the email for them. And then also the link at the bottom. So if you want to go and look over these options that I've just talked about, you can follow that link. So you can quickly take a screenshot or something like that before we move on. Okay, so let's jump into Creo. And that's the part we're going to do. I just quickly want to erase that. So we're going to start this from scratch. So it's basically for beginners. So we're doing it like that. So the first thing that you'll do is you're going to create a new manufacturing assembly. So if you have the manufacturing licenses, this icon or this manufacturing will be available. So you can see I have all the manufacturing licenses available. If you only have the machining, you'll have NC assembly, and expert machinist will be available over here. Okay, so let's call that. And I'm going to use my default templates. So that's the interface that you have when you go into the manufacturing. So you'll see you'll have very similar tabs at the top as you would normally have in Creo. The only difference is this manufacturing one where there's specific groups for manufacturing purposes. So how I normally drive this when I start off is I drive it from my reference model and I work my way to the right. Okay, so I'll start off with the reference model. I'll create my workpiece. I'll create features if I need to. Then I'll create my work center, which is my machine, and then I'll start with my operation. Okay, so let's do that. So I'm going to first start off, and I'm going to click the icon, and I'm going to assemble my reference part, and that is under milling. So there's the part that we'll be doing today. So I'm going to open that up. So as soon as you bring in that reference part, you'll see this interface is exactly the same as the assembly interface within Creo. Okay? So what PTC is doing, they're keeping that standard throughout the system. Okay? So that makes it a lot easier for a guy that's used to Creo to go into the manufacturing side. The truth about that is if there's a guy coming from just a standalone CAM package, then moving into Creo, you'll need to learn this interface a little bit. Okay, so for that purposes, or normally your first part is default constraint. So I'm just going to right click. I'm going to default constrain that. And you will see my OK icon is available, and I can click that. And it's just a warning message that the part accuracy for my assembly and my part is not the same. So at this stage, not critical. When you do mold design, that's very critical. So I'm just going to say, okay, I'm okay with that. And let's quickly have a look at this part that we'll be doing today. So let me just hide some of the datum planes, datum axis, and coordinate systems. Okay, so let's take a few measurements of this. So you can use your analysis tool or the analysis tab. Click on the measure tool, and let's get a few rounds so we can just see what radiuses are we working with, so we know what tools we'll be using. There we're sitting with the 20. It is all in millimeters. That's a 12.7, so that's a half inch. Sitting with 18 millimeters over there. What's this smaller one over here? That's 12 as well. What do we have in this corner? 20. So fairly big. Maybe this one here is a little bit smaller. 6. So we might have to get a smaller cutter in there. Just quickly see what's the width on this component. So 52. So that's about 2 inches. Okay, so use your normal tools, and once again, this measuring tool is standard within Creo. So really, if you've been using that in Creo, then it's not going to be any trouble in here. And then we have a 10 hole as well. Okay, so now I more or less know what tools I'll need, so I can set that up if I when I set up my machine if I need to. Okay, so let's go back to the manufacturing. So let's create our workpiece. So as soon as we click the icon, Creo is going to take the minimum size for my workpiece, and it's going to draw a boundary block around that. Okay, so I can OK this, or I can fiddle a little bit around with it, change the dimensions. So let's round that off to 160. And let's make this one to 61, just giving us a little bit of meat. And let's make this 53. Okay, so you'll notice if you click on the options over here, those dimensions that I've just entered, it did them in the positive direction and in the negative direction. So my part is still in the middle of this stock that I've just created. You can go and you can drag these icons over here, and you can make it bigger to the bottom if you need to. So if you're going to put it in a vise, something like that, you can add a little bit of material in there. One of the other options that you can do with your workpiece is you can assemble a workpiece. So if you're doing castings, things like that, and you've created the cast model, you can assemble that model. So if you pick that, you go and you browse to your component and you assemble it like you would do a normal part, or like we did the workpiece that we've just done. So I don't have anything like that. I'm just going to use my normal automatic piece. I'm going to make that 160, and I'm going to make this 261. And then I'm just going to add a little bit at the bottom, about 5 moles of material over there. And there's my workpiece. Okay, so the type of feature that I'm going to use here is basically driven from a collet. So it's a 5-axis method of holding your material. So I need something on this workpiece to hold that. So what I can do is, this workpiece is a normal Creo part. So I can activate this, and I can create extrudes or anything that I need on this. So you'll notice that my interface here at the top, my tabs changed. That's because this part is active now. So I'm in part mode now, and I can go and create extrudes. So I'm just going to use the center, or find the center first. And then I'm going to draw a circle. I just need to delete that constraint to give me a dimension. Just adding to this workpiece. Yeah, so later when I need to make drawings of the workpiece for the shop floor, I can do that as well, because it's a normal Creo part. So drawings, everything is exactly the same. I'm just activating my main assembly again, and there's my workpiece. So the next thing that I can insert is the vise, or the holding method that I will be using. And I'm going to bring that in. That's going to be this guy over here. So let's get it more or less into place where I want to place it. And I'm going to use normal constraints. That center. See that? And I'm going to have a little bit of an offset between. So that surfaces are coincident now. So I just want to change that to a little bit of a distance, just to give my cutter a little bit of a clearance. I want to cut into this. The 2 mils should be sufficient. And I okay all of that. Yeah, so there's my feature in there now, and I can start creating my machine. So we've done all of this now. So the type of machines that you can create. So we'll do a milling machine now. You can do your Mortons machines here, your lathes, your wire EDM, and you can also have user-defined work centers. So if you only have 3 or 4 work centers on the shop floor, go through this only once and you save that work center. Each time you'll use it, you'll just bring it into your assemblies, and you can have tools and your basic setup done already. So one of the nice things in Creo is that you can save all of this information. I'll show you when we start with the tool parts as well. That information can be saved, and when you start off with Creo, you won't be able to remember everything. So save as much as you can and reuse that information. Okay, so we're going to create a milling machine. For this part, we're going to use a 4-axis machine. Excuse me. We're going to drill these holes from the side. So we'll do those holes from the side, and we'll need to position it like that. And we might need to do a little bit of a milling over here as well to get that hole. Okay, so we're going to change that to 4-axis. And we're going to tell it we want to use rotation. And these settings is determined by your controller on your machine. So will it be incremental or absolute? Do you want it to take the shortest distance? Do you want it to turn clockwise or counterclockwise? And then what is your axis? So most of the time that settings will link up with the post processor that you'll use, and we'll sort this out first before we start with the post processor development. Okay, so we can enable probing as well. So if there's probing capability on the machine, then you can add that as well. We're not going to use it in this specific demo. Okay, so let's create our machine. That's the machine. Machine is done. Okay, so the last one now that we need is the operation. So you can have multiple operations. You can have different coordinate systems that will define your G54, G55, 56, and so on. So you can have all of that either in one operation, or you can break it out into separate operations. You can also have different operations for different machines. So I've created a milling machine now, but if this job is going to go to a lathe after this, or to a wire EDM machine, I can go and I can create that wire EDM machine. And you'll notice in my model tree that I have the milling and a wire machine in there. So that's also a nice thing that you can use to keep one file on your hard drive or in Winchell or wherever, and then you can have that whole process within that one file. Okay, so that's just another way of doing it. I'm going to delete the wire machine. We're not going to do that now. And then on the operation. So this time I'm going to do it a little bit on the fly. We need a coordinate system. So this is your normally your G54. That's where the guys need to pick up the part on the machine. So normally you'll use the center of the stock. You can use corners. If there's holes already in it, they can use existing holes. The important thing is whatever you use here have to match up with the machine, because everything is calculated from that specific point. So on this one, I'm going to create a coordinate system. Okay, so this is, hope you guys can see that. So there's my coordinate system. So I can either do it from here, or I can cancel this and I can create my coordinate system first. So let's let's create the coordinate system first. So I'm going to select that surface over here and that edge. Okay, so then I need to specify my orientation. So where's my Z, where's my X axis, and where's my Y axis? Okay, so orientation, so that surface, I want that surface to be my Z. So that means my tool is going to approach from the top. Remember, we're working with a 4-axis machine here, so we need to specify that. And then I'm going to use this edge over here, and I want that to be my X axis, and I'm just going to flip that around. You can see my positive direction is showing to the left hand side of my screen. I want that to go to the center of the part, so I just flip that around. Okay, so now the guy on the shop floor, you'll need to pick up this corner to machine this component, and let's call that the G54, so we know that's there. Let's quickly show our coordinate systems. So there's that. So this is the part coordinate systems, the stock coordinate systems, and the feature coordinate system as well. Okay, so that's the first steps. That's the important ones before we create our operation. So the operation, we're going to tell it to use that G54 we've just created, and under my feature setup, I can go and select the one that I've just done. So there's that. So once again, here you can have more than one, and you can chop and change as you need it. Okay, and now you'll notice that I've got the milling tab available here at the top as well. So you have to go through this manufacturing process, this startup, which is basically your setup for your workpiece. You need to do that first before you can actually go and start creating roughing sequences, finishing face and profiling, things like that. Okay, so you have to go through that first. Okay, so we've got all of that, so let's start creating that. So I'm going to create a few things on the fly now. You don't have to do it like that. Normally you'll create your mill windows first. So that's just a way to tell Creo, I'm going to machine in a certain section now. So you can either do it like that, or you can start the roughing tool, and it's going to highlight everything that you need. Okay, so I need a tool. I need a mill window. I need to tell it where do I want to machine. I need to set parameters like cut feeds and speeds, and how much stock I want to take, step overs, things like that. And then I need to specify my clearance plane. Okay, so all these in yellow is the minimum things that you have to specify. Okay, so tools, we can create it from here when we want to do that. So that's the tool setup. So yeah, I just quickly want to go back to the machine setup. So if you cancel this, and we cancel our roughing, and we go back to the manufacturing tab, and we go to our work center, that over there, but we're just going to edit definition, this one. We go to tools, and we pick tools over here. So you can see those two windows was exactly the same. So it doesn't matter where you set up your tools. Maybe you didn't inspect the part at the beginning, so you couldn't have known what tools you'll be using. We've done it in the start, so I can create a few tools here. So I'm just going to create an end mill, and it's going to be a 16 millimeter end mill. Let me just quickly go through that as well. So here's all the tools that you can create as well. Okay. The nice thing when you do it on the fly, it will choose this automatically. So if I'm busy with the drilling sequence and I don't have a drill, and I go into the tools, then I can only create the drill because I'm busy with the drilling sequence. So I'll show you that when we go to the 4-axis bit. So end mill 16. What did I say? That part's about 50, just over 50. So we need about 55 millimeters of flute. and we can make that 75 to the collet. And okay, and we okay that as well. Okay, so now I've created my tool within my work center. So if we go back to milling, I'm going to start that roughing again. Now those tools are available. If I didn't want to use a 16, I wanted to use a 10, then I can go to edit tools. I'm going back to that specific window. I say new, and I say I want to create an end mill, but I want to create a 10 millimeter. Specify that. We'll need 55 flute, and let's make that 65. And now I've got that tool in there as well. And now I can select any of those. So everything is linked all the time. Okay. Also important over here, this is the coordinate system that we'll be using. So if we had a G55 or 56 or any of the others, then we need to specify that. So then we need to tell Creo now, okay, so where do I want to machine? Do I just want to do this pocket over here, or the center pocket, or do I want to rough out the whole thing? So we'll need to specify that. We need to tell him that. So if we go onto the right hand side of the screen, you can create your mill window. So then there's a few ways to create that. You can do a sketch, or you can select edges, things like that. I'm going to go for the edge selection. So I'm going to pick a plane. I'm going to pick the plane on the part. That's the one. And then I'm going to pick the edges over here. So I'm just holding shift down. That's grabbing all the edges in one. So I don't have to go click one at a time. So one edge, shift, and it's going to grab all of that. So then I can specify how deep do I want to cut this. So remember, we're sitting with a feature here at the bottom. So we don't want to go into that. But we also want to go through the part. So let's specify that. So it's going to start from there, and then we need to go through just about there. Let's make it 57. That's going to be, and I need to go more. 58. There you go. We're breaking through. And we're not cutting into our clamp as well. Perfect. Okay, so you see that 5 millimeters I added in there was maybe a little bit too much. I can go and I can change that if I need to. Okay, so that's our mill window. We specified the depth that we want to machine. On this particular part, we can do it outside as well. And that should be fine. Okay, so you'll notice that we've got a few extra parameters in here now, or it calculated the cut, feeds, and everything for us. So that's just the relations that's included now. It's just a start thing, so you can see it. I won't always use it. It depends on your tools that you have and everything like that. So normally I'll change this. So we're sitting with it. I need to change this as well to the 16 cutter in any case. So I'm going to go for a smaller step over, and I'm going to cut a little bit deeper with this particular tool. So these settings will be determined by the tooling manufacturer. That's the only things that I really need to specify in here. And I need to specify the clearance plane, so I can select the surface, and you just take your drag handle and you drag that up. You can see exactly where it's going to go. Okay, so let's just make it for this demo a little bit higher so we can actually see where it's going. When you're doing your parts, it will be a little bit tighter than that. Okay, so let's quickly go through the parameters, because it's very similar for all the type of sequences that you will be creating. So when you pick the tab, it's going to give you all the important ones in this small window. If you pick the icon here at the bottom, it's going to open up a different window, and you'll have a lot more things that you can adjust. Okay, so what I normally do is I click on to show me everything, and then I use the categories over here, and that narrows it down a little bit to what you need to set. So feeds and speeds, so there's free feed, approach feed, exit feeds, all of that you can set in here. You go to the next one, your cut depth and your allowances. So here's that step over 3 that I've adjusted, it's in here as well, and the step depth as well, that's 5 mils. Now I can go and I can adjust them. I haven't done the stock allowance, so I need to leave a little bit of material. So I'm going to leave 2 mil material on the side walls, and that's about that I need to set there. Let's quickly go to the cutting motions. So I can change this to be a more constant load, and you can go through it. So it will give you a little picture of how that's going to cut. So that's also going to change with the type of pockets that you machine. So we can keep that one, and trim to workpiece is set to yes, that's fine. Okay, so cutting motions is fine. Entry and exit, so it's going to come in at the 90 degrees. That depends on, well, it's coming in with a tangent helix as well at 90 degrees, so you can adjust that if you need to. Approach distance, things like that. Let's keep that standard for now. But normally go through these, set them, and then you can go and you can save as. So if you have a specific cutter that you like to use for roughing, get all the information, set this up, take a little bit of time, go through it, save that file. Anytime you use that cutter, you can just go open, browse to that file, select it, and it's going to do all these parameters for you. Okay, for starting up, that's gonna help you a lot, and you'll be learning a little bit of the parameters as well at the same time. Okay, so let's keep the rest of it like it is. Then you don't have to okay everything to see the toolpath. Creo now, you can view that in the graphics window before you complete everything. So it's gonna regenerate that. And then we have the PlayPause Viewer that we can use. So we're just going to make this a little bit slower. We're going to actually see how this is going to start. So it's coming in from the side. It's taking that 5 mil cut. And that motion is set by that constant load that I've added. You can see it goes a little bit deeper in there. And it's going to work its way through this component. So let's speed that up a little bit. Okay, so maybe that constant load wasn't the best setting for this component. Let's work it through so we can just see where it's machining, where it's not machining. And then it goes through to the bottom. Okay, so that's fine. Maybe not the perfect sequence, but we can go and you can play around with that. So now we can go and we can change that constant load to maybe maintain cut type or direction, and that's going to update. So let's see, maybe that's a better one. It's going to calculate again. It's a little bit different, not that much. Yeah, but the calculation and everything is fairly quick there. It's using the 64-bit capability of the latest machines. So you can go through those options and pick the best one. Okay. Just quickly wanna. Okay, so it's rotating. I'll maybe a little bit of a delay on the screen there. I'll try to rotate it not as much. Okay, so that's the roughing. that we can use. The next one will be a re-rough. So let's use that 10mm cutter, and that's going to basically calculate the re-roughing from the first roughing that we've done. We're going to use the same coordinate system. We need to change our parameters a little bit. This is a 10mm cutter now, so we'll step over, maybe make that 2 rough stock allowance. Let's go to size on this, so it takes a little bit of material, and we can go, let's say, 3mm deep. Okay, and let's see what that's going to give us. Okay, so it's cleaning up the surfaces, and it's going into a few pockets that we need to maybe do differently. So it's going in here. The 16 didn't go in there, and the 16 cutter also didn't go in this particular slot over there. So maybe take a different approach on that. Okay, so for this thing, I think we're going to leave it like that. In real life, please don't do that, because I want to go to the 4-axis stuff, and we're running a little bit out of time here. So let's go to the 4-axis. So the next thing that we'll need to do is we'll need to drill these holes over here. So I'm going to show my coordinate systems and my datum axis. So the way that Creo calculates these rotations is the coordinate systems that you set up. So we've got a coordinate system over here, and then we're going to create a coordinate system over here on that particular surface, and the Z direction of the coordinate system will determine from where the tool is coming. So let's quickly do that. So we're going to create a coordinate system. It's going to be on the center of that hole, and it's going to sit on that surface from the part. So again, we need to specify where our X and our Z and our X direction would be. So the surface was our Z, and then we can use this edge over here to determine our Y. So that's going to give us a coordinate system like that. So I'm just going to leave my screen so you can see exactly what I've done there. And we can say OK. So now we're going to create a drilling sequence, and we're going to use it, tell it to use the new coordinate systems that we've created. So you'll see again, you'll need to specify a few things. I'm just going to create a tool quickly, and it's going to be a new drill. And I can't remember that hole diameter. I think it was, let's quickly measure it again. 12. Okay. Then we're going to use a 12 drill. It needs to be fairly long. So let's measure that as well. So from this surface, there, 140. Yeah, that's deep drilling. Okay, so this needs to be at least 160, and let's make this 150. Okay, and then we need to specify reference for the drill. So we can specify the axe that it's going to use. There's the axis, and we can tell it, can it calculate automatically, or do we need to specify that? I'll come back to that now. I just want to fix this clearance up before we move on. So we want about a 10 mil clearance over there. Okay, so let's get back to this. So our start depth, we can either select that, and then we can tell it, do we want to drill up until a certain surface? Let's do that first. And there's our drill. Okay, so let's view what's going on here. Okay, so that's drilling that. So you can also use this positioning, and you can pick a point on that toolpath. So we might need to go a little bit deeper in there as well. Did I pick it right? No. Yes, so it's up until the shoulder of that. So in real life you'll need to go a little bit deeper. So let's go there and let's specify our own depth. What did we measure? So let 150 should do that. Yeah, that's a lot better. Okay, so we'll need a little bit more flute over here. So we need a specific drill for that. Okay, and the point that I wanted to make with this particular sequence is that you create those coordinate systems when you're working with 4-axis or 5-axis, and it's just going to position your tool a little bit better. If you look at the actual CL data, so this is the code that Creo is generating for the post processor. You will see there's a rotate command on the B axis. It's going to rotate 90 degrees. So depending on your machine and the post that you're using, that will orient the component to what you need. Okay, but how you do it stays exactly the same. Okay, so then I'm going to leave it there. So I'm not going to finish this component. I'm going to quickly go to the simulation because that's also new in Creo that they've added, I think, in a certain release of Creo 4. And that's the new simulation that's available from ModuleWorks within Creo. So the old users, they can remember very cut that we've used, so that's not there anymore. It's the specific one now. So I'm not going to follow the tools. I'm going to keep everything fairly basic. And you see this window, very similar to the one we used with inside Creo. And that's our roughing sequence. So now you can see it's fairly different from that constant load one that we've selected. Inside here, it's going to give you a collision report as well. So as you work through this component, if the shaft or anything like that is catching onto the stock, that will show you that. Okay, so I'm just quickly going to check if there's any questions. So maybe start asking those questions, and then we can, if there's not questions, then I can maybe show you one or two more things. Okay, so that's the simulation. You see we've got some of our holding material away here, so that's really not ideal. So that depth that I've set, I need to bring that up a lot. Okay, the depth that I'm talking about is in the mole window. That one, that needs to be more or less at I would say 55, or we haven't done a lot, so we can regenerate that. Now let's play that port. Speed that up. See how deep. Yeah, that's not as deep, so that's a lot better. Okay, so let's check the questions quickly. Okay, nothing. So let me show you one more four-axis thing. So this area, I'm just going to hide the stock for this particular one. And we can hide the coordinate systems as well now. So the edge that we want to machine now is we can get a fairly good finish on this edge if we're coming in from the side like we've done with the drilling. So we already have the part orientated in that position, so we can just reuse that. So we've done the drill, so let's use the trajectory milling, and we're going to use that coordinate system, and we're going to use the 16 end mill, and we're going to create our trajectory. So you just pick your points. So instead of using a ball nose to go finish these surfaces up, you just use an end mill and you go through that once. So start height's over there, and the height's going to go to there, and there we go. So that's it. So once again, you can go into the parameters over here and you can set your entry and exits, exactly the same things as in the roughing. So all these parameters are very similar. Okay, so we can give that let's give it a 5 radius. Yeah, that's the one. And then need to say lead in and lead out. And you can see there's my leads in and lead outs. Okay. And we can view that toolpath as well. So we're kind of coming from that was a little bit too big. Slow that up a little bit. Yes, in this particular one, we're retracting all the way with every slice that we take, so we might need to change that as well, just to make it a little bit quicker. If it's a once-off part, not a big issue. If it's going to be a production part, then we need to get that toolpath as short as possible. Okay, so that's it. So I think the main area that I wanted to show and get the beginners comfortable with was the interface. Set them at ease that most of the things are very similar. Your parameters and things like that is similar in all of the type of sequences that you create. If you're already using Creo, going into manufacturing, that's really going to be easy. The sketches that you need to create, the things that you need to pick, that's exactly the same. Okay, so I'm quickly going to go back to the slide. So if you need my contact details, that's it, and take that down. Send me an email if you have any questions. Just going to Okay, so is there any questions? I'm going to give everybody about, let's say, 2-3 minutes to get those questions in and then answer them, and that will be the end of the webinar then. So take your time, get those questions in. Okay, so we have 3 or 4 questions. So the first question, can I do Swiss lathe turning? I think there's not a particular Swiss lathe features within Creo, so we'll use the mill turn capabilities. So I guess it's a yes/no type of answer, and I'm not 100% sure as well. It depends on the Swiss type lathe you're talking about and what the capabilities is within that particular machine. In some cases, we'll be able to use the Molten capability within Creo to get that up and running, but that's something we'll have to check. So if you can send me the machine specifications or what type of machine you're thinking of, and then I can answer that question maybe a little bit better. And then we have a question, can we use the software for CNC machines? So definitely yes. We can drive most of the CNC machines on the market today, from your 3-axis machining to 5-axis, and your mill turn machines can go up to sometimes 7 or more axis. So yes, we can definitely drive those CNC machines. That part where I've showed the code, that's the type of code that will go through a post processor, and that post processor will convert that into a language that your type of machine can understand, and that will drive the tool and cut your parts. So answer to that, definitely yes. Okay, so any other questions? I'll give you a few more minutes to get those in if you have any questions.